Implementation and control to assignment and control systems. Control systems made simple. Understanding control systems from a basic concepts to a system components. What are control systems? A control system is a framework that automatically manages physical processes to preserve desirable conditions in the context of instrumentation and control. It measures variables such as flow, temperature, and pressure via instruments, and it compares results to a set point and modifies actuators to remedy the deviation.
So to start with the most simple control system that we'll be doing today of the tool, let's start with an open loop system. Open loop systems strive in their simplicity. The basic concept of an open loop system is there's a type of control system that is operated without the knowledge of the control variable. So to explain, information is going in when you do an input, you put in an input, and then you get something out of it. The process happens, you get something out of it. Notice how no information is going back, no feedback is going back, nothing is being modified after activation. It's activation, process does whatever it is that you wanted the input to achieve. So the advantage of this is that the simplicity leads to it being cost effective. A lot of the systems that you would see in your everyday life would be open loop systems. And now let's go over some examples of those. So one incredibly common open loop system is a light switch. So we want to change the light to on. We go to the light switch, we flip the switch. That is the input. Flip the switch, a process happens, the light begins to glow. That's the output. No information is going back to modify the brightness of the light. Here are the basic components of a open loop system. So as I've been saying before, we have the input, which is the desired value or command that is given to the system. We have the controller, which is whatever processes the input and generates a control signal. The actuator would then receive the control signal and it would act on the system. The system itself would be what is performing the actual task. And finally, the output, which is the result of the process. So incredibly system that is a open loop system.
What are closed loop systems? A closed loop system or a feedback control system is fundamentally defined by the presence of a feedback loop that allows it to self-correct. This design is what makes it a core concept in automation and process control, in contrast to an open loop system which operates without checking its output. Operation. The control action is dependent upon the output. It uses a feedback loop to compare the desired input with the measured output to calculate an error signal. The advantage of this system is it's highly adaptive and precise. By always correcting the error, it can handle unexpected disturbances and maintain the desired output with high accuracy. Examples of closed-loop systems in everyday life would include a home thermostat, which measures the room temperature, turns the heating and cooling system on and off to maintain a set temperature. Cruise control systems in cars measures actual speed of the vehicle and adjusts the engine's throttle to maintain a set speed when going uphill, downhill, or maintaining distance behind a vehicle. Adaptive suspensions on car systems measures the vehicle's dynamics and adjusts the dampers in real time to match the driving conditions. What are the essential components found in every feedback system? Four main components would be the error detector, controller, plant, and sensor. Every closed-loop system is made up of the input, sensors, controller, which in the example would be the ECU, the actuator, which would be the damper, and the plant. In this system, we'll be focusing on an adaptive suspension system. The sensor, these are the eyes of the system, acting as a feedback element These measure the process variables, which include wheel and body acceleration, suspension travel, steering angle, brake pressure, throttle position. The ECU, also known as a controller, is the brain that receives all the sensor data. It compares the actual motion to the desired motion of the driver's needs. It calculates the error signal and then executes an algorithm to determine the precise dampening force needed. Dampers are the actuators, are the final control element that execute the corrective action. These dampers can be either semi-active adaptive suspension or fully active. Semi-active, the ECU sends a current to the valve or magnetic fluid in the damper. This electrical signal instantly changes the damper's resistance, stiffness, or firmness. In fully active suspension, actuators can actually inject or remove energy to physically raise or lower the chassis, providing an even more precise control.
Between open and closed loop system based on feedback control system are classified as either closed loop system or open loop system. Without input, open loop systems are less accurate and do not automatically fix themselves. They are inexpensive and easy to execute. Closed loop systems generate an error signal that directs corrective action by monitoring output and comparing it to input, although they are more self-correcting and accurate and dependable. They are also more complicated, expensive, and need to be adjusted for stability. These are the members of Group F: Corey Barrett, Antoine Johnson, Ali Maitland, Chandra Phillips, Credits, University of Technology, Instrumentation and Control. The references, that is all. End of video.